Hello everyone, welcome to Olsen Cafe. Today in this video, let me show you not just the laws of logarithm, but also how to prove them and avoid the traps most students fall into. So let's begin. So here is the first law. Let me define what is x and y in log form. And to prove this law, we will need to apply the basic, which is changing the log form into index form. So if you are not sure how and have not watched my first video on changing the log to index form, please watch it first before you continue with today's lesson. All right, now let's continue. So over here, what I'm going to do is I'm going to rewrite, this into index form. So I will have base to the power of x, which is equals to a. So similarly, I can change log base a of n equals to y, to a to the power of y is equals to n. Now, so since I want m times n, so therefore I'm going to put these two together. So n times n, this will give me a to the power of x times a to the power of y. And if you are familiar with laws of indices, you know that I'm able to rewrite this using law number 1 to give me a to the power of x plus y. Now at this point, what I'm going to do is I'm going to change this index form back to log form. So to do that, again, I will need to identify the base and the and index. So changing it to log form, this is what I will have. And now what is x and y? I know that x is equals to log base a of m and y is equals to log base a of n. And with this, we are done with the first law, which is what we call the product law. So let us move on to the second law. So we are going to use the same approach to prove this law. So again, I'll define what is x and y in log form, and I'm going to change them to index form. So over here, what I have here is, since I want m over n, so therefore again, I'm going to write here m over n. So therefore with this, I will have a to the power of x divided by a to the power of y. So again, using laws of indices, law number 2, I know that I'm able to rewrite this as a to the power of x minus y. So again, we are going to change this index form into log form. So to do this, again, I need to identify the base and the index. So base is a and the index now is x minus y. So I'm going to rewrite this into log form. So that means I will have log base of a. So therefore, this will give me log base of a m over n, which is equals to the index, which is x minus y. So again, what is x and what is y? I just simply replace the x and the y by the definition. So with this, again, I am done with the second law. And this second law here, is what we call the quotient law. Here are two examples of how we can apply the first two laws that we have covered so far. They are very simple. All right. So the first one, so do take note that over here, all right, the both log functions, we have the same base. So again, I'm going to apply law number 1, which is the product law. So by doing this, I'm able to combine the two log functions into one and hence give me log base a of 15. So similarly, if I look at the second expression here, there are two log functions with the same base. So since it is minus, so therefore I know that I'm able to apply the second law, which is quotient law. So to do this, I'm able to simplify it into a single log functions, and this will give us log base a of 5. Now, these are very simple, but what I would like all of you to take note will be the common mistakes that students often make. Do pay attention to them, because this mistake may seem small, but one small mistake, but it have a huge impact. So you may want to take note of this page. So the first common mistake that students usually make, is by combining this. So they just simply take log function as, like an alphabet, and they just factorize out the log function, which is strictly no. And then the second mistake that student made, that is mistake to the first law, it is the product law. It is, they just thought that, oh, I can just, take it as, again, algebra. I'll just put the bracket together. So it's again not true. So the last one, the common mistake for quotient law, so students tend to just, multiply the log into the x and multiply the log into the y. So do take note, log is a function and not algebra. let's take a look at a more complicated example. So over here, I would like to remind all of us again that we do not factorize out the log function. All right, log is a function and not algebra. So what I'm going to do is I'm going to apply law 1 and 2 together, which is product law and quotient law. So we see that there is a plus sign here. That means I am able to apply product law. And then subsequently, when I see all the minus, that means this will associate with quotient law. So I'm going to do that. So by applying these two laws, this is what I have, all right, the first step. Now, if you are not able to see how I derive this first step, so you may want to take a piece of paper, applying the law one at a time. All right, so you should derive this first step. So that means you take out these two laws first, applying product law, and then once done, then you apply, all right, to the next function, and the last one. So you should derive this first step. Now that I have this, I'm going to write it in fraction. So this is what I have. I can see that all these numbers I can easily simplify. So what I'm going to do is I'm going to simplify them. So 6 at 27. So I'm going to reduce all this to the simplest form, and therefore I know that I'm able to derive and simplify till log base 2 of 1. Now, are you able to recall what is log base 2 of 1? All right, so if you have done watch my previous video, right, my first video, you will recall that this is actually under the special logarithm. So this is equals to 0. How do I get this? Because any number to the power of 0, it is always equals to 1. So it's 2 to the power of 0. This will give me a 1. So again, if I'm not sure, do check out my first video. Now over here, since we have done quotient law, so I'm going to use quotient law, all right, to illustrate to you how I get this. So again, if I look at log base a of 1, I can simply rewrite log base a of 1, the one, and replace it by b over b. So by applying quotient law, again, you can see I have the answer, which is equals to 0. So are you convinced now? So we are ready to move on to the third law. So this third law, so again, I am going to define what is x, all right, and I'm going to again convert this log form to index form. So with this, I get a to the power of x equals to m. Now, so again, what I want you to take note, right, because I want m to the power of n, isn't it? So therefore, what I'm going to do is I'm going to apply the index n to both sides, right? Take the power of n. So with this applied laws of indices, I will be able to get a to the power of x times n equals to m to the power of n. So what I'm going to do now, which is similar to what I've done for the first two laws, I'm going to convert this index form to log form. So with this, I have the base, I have the index. So what I'm going to do is index is going to be on the right hand side of the equation, isn't it? So what I'm going to have is I have log base of a, all right, of m to the n, and the index xn is on the right hand side. Now let's take a look again. What is our x? Our x is actually equals to log base a of m. So I'm going to replace this, all right, and this is what I have. So by rewriting it, all right, so I have n to the power n times log base a of m. So this law, all right, is what we call the third law, which is also called the power law. Why is it power law? I simply bring down the power, which is the index, to the front of the log function. So hence this is called the power law. Okay, so let's see how we can apply power law in these two examples. So the very first one, what I have here is there is the number 2 in front of the log function. So by applying power law, I'm able to bring this index to, all right, to 3. So I have log base a of 3 squared minus log base a of 4. So since there is a minus, I know by now I'm able to apply quotient law. So to simplify this, I will be able to get 9 over 4. Now let's take a look at the second example. So the second example here, I have 5 to the power of 4. So again, I know I am able to apply power law over here to bring down the 4 to the front of the log function. Now let's take a look at the second log function here. Now the second log function I have is a base 16 and the number is 1 over 4. So am I able to see any relationship between 16 and 4? So I know that 4, it is actually square root of 16. So I'm going to apply all this, all right, in simplifying. So this is what I'm going to have. So now, so can you see I have log base 5 of 5? Are you able to see any relationship? All right, so there's a clue that we can actually simplify log base 5 of 5. And then 1 over square root of 16. Again, I apply laws of indices. I'm able to rewrite this into the negative indices. All right, so again, I see that I'm able to apply power law again. So this will give us, all right, I bring down the negative half. All right, this will give me this. Now, can you see log base 5 of 5 and log base 16 of 16? So do you know what will we get here? So these two, right, is actually based on another special logarithm. So I have base to the power of 1 is equals to a, right? The same number. So therefore, since the two numbers are the same, I know that these two will give me a 1. So therefore, to simplify, and hence I get answer, which is 4.5. So let us take a look at this last example in this video here. Now, so you notice that the log function that I've written here, it looks slightly different, all right? Over here, I write it as LG. So this is when I'm going to introduce a new term here, all right? LG, which means it's a log function base 10, all right? So therefore, in the representation, we just need to write down LG. So each time when you see LG, it simply means it's a log function and the base is always a 10. Now, so let's see how we can simplify this. So again, you can see that we have a minus here. So that means this is a clue that I'm able to use quotient law. And then each time when I see a plus, that means I'm able to apply product law. So by using this, I'm able to put this together. All right, so what I'm going to do is, there's a square root, right? So I'm going to apply cert. All right, so which means I combine these together. So 175 divided by 91 times 52. So I know I'm able to simplify this till I get 100. Now, what is 100? Square root of 100 actually gives me a 10. Now, what is log base 10 of 10? Because since LG means base 10, right? So that means I know that this value here, all right, will give me a 1. Now, over here, what I would like to caution all of you, right, is this: a lot of students, all right, tend to make these mistakes, which is over here. All right, this is a mistake whereby students often make. All right, so why is that so? Because they simply look at this divide by square root of 91 times square root of 52, so which is from here. So do take note, these two are not equal, right? They are not the same, all right, because of the 52 here. Now, so if I'm going to use another method, right, I will be able to show you why is the error, yeah? So if I'm going to do this, so what I'm going to do is I'm going to actually to put a bracket, all right, for the last two log function. So you know that when I put a bracket for the last two log functions, right, you notice that this sign here that I get, it should be a minus, all right, because from a plus, right, it should change to a minus because of the bracket. Now with this, right, if I'm going to rewrite this, I will be able to have this applying quotient law. This will give me square root of 91 over 52. So again, I'm going to apply quotient rule again, right? So this will give me square root of 175 divided by this. So if I'm going to simplify, all right, in the end, I will be able to get 175 times 52 over 91 instead of the 52, right, as the denominator. So do take note of this. So again, with this, I simplify, all right, I will be able to get log square root of 100, and we already, all right, I already explained, all right, log base 10, all right, to square root of 100 is actually equals to 1. So this is actually how the question is being done. So I have covered all the three laws, all right, of logarithm. So those are the three laws that all of you will need to be very, very familiar with, because you're going to apply them very often. All right, so here is a summary of all the common mistakes that you should avoid. All right, so which I have covered already. So the first law, all right, do take note. All right, you cannot take log function, all right, as an algebra, right, whereby we just factorize out. So it's a strictly no. All right, and then likewise, for the quotient law, this is also something whereby, you know, to avoid. And lastly, all right, the last common mistake that need to pay attention to, all right, which is this. Okay, so do take note there is a difference when there is a bracket and when there's no bracket, so the log functions are different. So all this I will cover, I will go through again in my next few videos as I solve more questions together with you guys. Now that I have covered all the 3 laws of logarithm, what if I tell you that you can actually evaluate logs without using a calculator? Right, so that will be coming up in my next YouTube shorts, right? Also to look out for my next video on changing the base law. So do stay tuned. All right, so make sure you subscribe and I will see you in the next one. Bye.